Well, it's yet another day. There seem to be many of them lately. So what am I doing today? Well, I'm working on electronics, and I've had a few boards manufactured from PCBWay. I'll stick a link in the description if I get around to it, but this is not a paid promotion. This is purely out of my own pocket. Well, I had manufactured a few boards, and I realized after getting a little excited and destroying a couple of them that I had a problem with my circuit. I even melted a track off this one. And it turned out to be one simple little track that this track here should have gone that way. And to be honest, the software did warn me that my schematic and my PCB layout didn't match, and that was one of the reasons why. And I decided to go, stupid computer, you don't know what you're talking about. Well, it actually did. I should have trusted that. Anyway, it's easily fixable with a slight mod, and in the next version of the board I produce, I'll fix that. So what is this board? This board, and I think I've made mention of this in previous videos. I'll move my blue tack away here. This is a 12 volt UPS, or uninterruptible power supply, and it's designed so that you can have a battery supply and you can have a main supply connected simultaneously, and should the main supply or the other DC supply, whatever it happens to be, drop out, it will seamlessly switch over to the other supply. So I'm going to arrange a couple of clip leads here and demonstrate that for you now. So this has a little relay and a big capacitor and a diode to stop the capacitor bleeding back and running the relay. So if we connect this up here, you can see we have a green light that indicates we have main power. This blue light indicates our outgoing power, which had a bit of a flicker there for a minute. I wonder why that is. So if I suddenly then disconnect mains power, you can see that going on and off doesn't affect the output. It's very seamless. The first purpose I'm going to use this for is my NBN modem. And if you're not Australian, you've probably never heard of the National Broadband Network. This is where they took our existing services and phones and said, at some point we're going to cut your phone off because we're going to use it for a fibre to the node internet system, and gave us all VDSL modems instead of ADSL modems. And in some cases the nearest node is like 300, 400, 500 meters away. VDSL doesn't work very well on that. Not to mention that is when there's a power outage, because we don't have any phones that are actually powered by the telephone exchange now, they're all through the modem, and most of these modems are not supplied with a backup power supply. If you lose power, you lose your phones. So if we lose power, this should keep the modem running, and hopefully we should have internet still, and therefore landline phones. However, most of the service provider solution to this is to basically tell us to get a mobile phone, and that is not always a perfect solution for reasons I won't discuss today. Yes, this circuit should have some other options and uses in the future. It's still a little prototype at the moment. I'm still waiting on my DC power sockets to arrive as well. It should look a little sexier when that's done. And I'll probably get some corrected boards ordered at some point. The other thing I did notice when I got these boards ordered is that if you do order something from PCBWay, make sure that you have any text you want on the same layer as the component silk screening, because they totally ignore any other silk screen layers. They didn't want to know about that. So consequently I have no polarity indication on the capacitor here, and no actual naming or board description or anything on here. So on the other hand, the white coating is very nice, and I think when I use my DesignSpark software, I'm probably going to request some bigger, or set some bigger copper pads in here, because the default ones are a smidgen too small. Looking at one of the other boards, this is a camera tester that I've used or designed. This is for Cat5 video balance. We've got one of them here. Basically these guys just use 3 of the Cat5 pairs for power and one of them for signal, and they have a little RF choke in there. But when you're dealing with people that haven't crimped Cat 5 plugs before, or Cat 6 even, they're inclined to get the pin out wrong. And so this is going to be a little safety device where you can plug the Cat 5 in and see if each one of the power pairs is correctly polarized. The little pin header here as well will allow diagnostic connections. One variant I'm experimenting with is one of these with a little self-powered voltmeter in here, and also having a power pass-through so that we can check power supplies, or use this as a cable joiner and tap power off halfway without making a dangerous join. And in this version, again, they forgot the silk screening on the top, so I've had to just write it in permanent marker. And I've stuck a white LED here so that you can use that as a light source should you need to just plug it into a power supply in the roof or into a cable. So that should be handy. But yes, the main project I'm working on, this thing is actually working fairly well. And I'm sorry I didn't have too much video of the actual build. These are the first boards I've actually had manufactured professionally, rather than doing like photoresist or acid resist boards myself, and simply because these are cheaper than even buying prototype board. So I was quite excited to see my very first professionally manufactured boards. You know, I've been making boards for, well, close to 19 years now. I've been making boards, and this is the first time I've actually had one manufactured by a manufacturing service, because it's just so cheap. I was really excited, so I built everything off the bat, and then found out I had one little track wrong, which caused the whole thing to go wrong. But hopefully we'll have a bit more progress. When the rest of these components arrive, I'll start videoing that, and I'll add this onto the video as well. So yeah, I'll stop yabbering now, and I'll cut to, I assume, a few days time from now, when these components are here. Okay, so I got a little impatient, and I robbed a couple of sockets out of some old projects, and ripped one off a dead DVR board. Managed to pull that socket out of the corner there. So we'll see how we go from here. I'm going to plug this into my modem. This could be some tricky photography here, but this little cable I've got here, this feeds off my house battery, which is also supplying my distribution board. It's fed from solar panels, so it's currently doing about 14 volts, which is not too bad for it. It's about charged. My modem running on the main supply is up here, so fairly shortly I'm going to hook them all up. Okay, well, I've got my main prototype board positioned, and I have the modem connected to this white wire. Got a couple of scavenged sockets because my other stuff didn't arrive in time. This is my battery lead, and this is my main supply from the DC plug pack. So let's plug our mains in, and our modem is on. Let's plug in our backup supply. Now, our backup supply is under load at the moment, currently about 12.5. the sun's gone away. Let's pull our main supply and see what happens. Relay dropped, and the modem hasn't been interrupted. So what we'll do, we'll let that get itself back and connected on the internet, and we'll see what happens when I pull the mains from there. Alright, so we have all green lights here, and our main power is being supplied. Down here I'm playing my Anzac video. So this is actually the first time I've tested this principle with the modem. So let's pull our main supply here. And our modem doesn't seem to have been interrupted. And the internet doesn't seem to have been interrupted either. It sounds like my apprentice is having a pants malfunction in the other room. That'll be interesting. But yeah, so we're running quite nicely off battery without interruption. Let's see if we reintroduce main supply. No interruption, and our video is still playing. I would call that a success. That'll be really, really good. Now, one thing I can do with my prototypes as they stand here is actually start to do some measurements. even though these is one of the boards that I've had to correct, I'm starting to look at making a 3D printable case. So I've started to do all the measurements taken from the measure function in Design Spark. This will be the new layout. For comparison's sake, here's the old one. You can see the tracks here, probably a bit more visible there. Not quite as robust, and the tracks on the pads rather on the old ones are quite uncomfortably small. So I've double sized them in this one, and I've also tried to increase the amount of copper on the board to help the current carrying capacity. That should uprate it a little bit. But yeah, from here I hope to make an STL file and probably a few other different formats, but at least I'll 3D print some kind of nice pretty looking case for it. On hindsight, I probably could have just designed this board to fit into a standard size case, but you know, doing things the normal way, that's not me. So let's see when the new boards arrive. I hope they won't be too far away. Now, the other thing that arrived today was some new power capacitors. These are electrolytics, or electrolytics, however you want to pronounce that. And these are the same 4700 mic caps, but these are 25 volters. The important reason why they're 25 volts is the original ones I've used here were 16 volters. And interestingly enough, the 16 volt and the 25 volt look almost exactly the same. So I'm not sure whether they're lying to me or whether I've just got some overrated capacitors. But in any case, at 25 volts, that will give the ability to run a wider range of voltages through this. There's really not too much that's voltage sensitive on here. I've got a current limiting resistor here of 390 ohms, and that reduces the current through the LED to about 20 or 30 milliamps, something like that. I've been using that value set for so long, I've forgotten the actual current value. However, I do know it's good from about 9 volts all the way through till about 19 or 20 volts. This resistor, or sorry, this diode here is a 1N4007. It's a 700 volt diode across the coils here just for flyback management. This one here is a 4004. It's a 400 volt. It should be fine as well. And there'll be a little ceramic or a polyester capacitor here just to help for when I'm using a mechanical relay in this, just to help absorb the spike until such a time that the diode can take effect. But in the final product of these, I'll be using a solid state relay, so that really may not be strictly necessary, nor will a flyback diode, but you know, they're going to go in there anyway because this is a kit form. And it is rather a simple circuit, more or less. There's nothing too terribly complicated about this. I think I've already been over the circuit diagrams in a previous video, but essentially the main power input lights this LED and holds the relay shut, which also connects that video. Alright, I'm going to have to cut this out. Now, sorry for that little jump cut. I had some speech problems. So the basic way this works is that on this bit here, this is our main input. It lights the LED, powers the relay contacts, which then passes through this diode to stop this capacitor bleeding back and holding the contacts open. That also then connects the main power through to the output and also powers this LED here. When the main power is lost, this capacitor will then power the load for the amount of time it takes the contacts to drop, thus switching in the battery connection. And this diode here stops the bleed back of the current, meaning that it doesn't hunt in and out. Very, very simple but effective, and I've made this on breadboards so many times it's not funny, and I finally decided to get a proper board manufactured for this to do the job. And there probably are many other solid state ways of doing this, but I needed something very simple and very reliable, and also through-hole components to make it serviceable. So yeah, hopefully some bits have arrived for me. Okay, I've had a little bit of a donation. had some of these arrive, so let's see if we can fit these up. Okay, so right away I noticed when I go to mount these are a different style to the ones I have wanted, but I think I can just fold up this extra leg. It's largely superfluous, and I'm not sure if you can see the silk screen on the board, but those two connections are actually bridged, so that won't make any difference whatsoever. Let's get these modified, mounted and soldered in. Okay, so I've got one stuck on with blue tack for the moment. Whoop, and this is what we're doing to them. We're just folding up that third leg out of the way. That's how they are before we fold the leg up. So I'm using some 1mm 6040 tin lead solder, and I have my extraction vent going off to the side here. Probably should have bent these pins up. When I've designed these boards, I've designed them a little bit, the holes a smidgen too big for the task. So I may need to fold these over. Now there's a bit of solder on there, it may or may not happen, but we'll get this in. This is one of my first prototype boards where I had an incorrect track on the board. So this little red wire here is a little bypass for one of those tracks. And you see right about here I've drilled the track, break it so I could bypass it. Right, so we have one socket in, we've got two more to go. Alright, and just like magic we have 3 sockets installed. This is starting to look useful. Now let's have a look at where this is actually going to get used. Now you'll have to ignore the state of my desk at the moment, it's been a busy week. This is actually a prototype solar powered demonstration unit that's actually produced by a company that I consult for. We're going to be testing this unit in here to run a battery backup. This is primarily designed to run off mains supply, but in the event of a dropout we want to be able to run off battery. So we'll be putting a 7 amp hour sealed lead acid in here and using this unit to control the power. I'm not sure if these will hold up to the 4 amps or something that we need to pull through, but the new design of board most certainly will. So let's get this all mounted up. So right now there's not too much in this box. There's some temporary cables here. One of the jobs I have to do with this is actually to shorten these cables up and make a nice little distribution box. But to give you some idea how this thing fits in here, this is our output and this is our camera cable. So we literally plug, I'm going to have to do this two-handed here, one-handed. We literally plug our jumper lead in there, and our main supply lead comes all the way over in the top right here. Sorry about the camera work, guys. So literally that's how we work. And then our battery goes in here. Can't be much more simple. I've put a little bit of black tape over here for the moment. This is prototype testing, so we'll plug this in a moment and see how she goes. Alright, so this is what we call smoke test time. We're about to turn everything on. Oh, that looks good. I'm hearing all the cameras fire up. Both lights are on, and we should see this little guy whiz around in the box. That certainly means he's getting power, and he's setting himself up. Alright, that's looking good. Let's get a battery hooked up. Alright, to simulate a battery supply, I'm using one of these little banana plug connectors, and we're going to swing our patch lead all the way over to our DC battery supply here, making sure that my polarity is correct. It's easy to get wrong. So now, if we position our camera carefully, which I might do in another take. Alright, this is a bit of a bodgy angle, but we'll see how we go. If I now pull our main supply, we should, without interruption, see our system work, and I notice that, oh, okay, that didn't work. I need to find out why. Alright, so it turns out the problem was I was using a 5.5 2.5 plug and a 5.5 2.1 socket, and the center pin wasn't making connection. This is another plug pack that is also 12 volt, but it has the correct pin. Let's try this. We'll pull our plug right here. That looks better without interruption. It has worked nicely. And we'll try again. That's looking very good. Okay. It is quite warm underneath. I'm wondering if that's not a circuit track that's carrying a little too much load. And the area of warmth is along the edge of this relay right here, which is where the main output load is being carried. So I think the new revision board will probably solve that issue. Alright, well there's not much more I can do on this project for now. The new boards are on their way. Postal tracking says they'll be here soon. Other components say they'll be here soon, but we all know ordering stuff from AliExpress can take as long as ordering stuff from Wish, like, 6 months. So yeah, in any case, once I get all this assembled, there'll be a part 3 video, and I've got some ideas in that where we might even go and get some stuff assembled. So yeah, we'll see how we go. It sounds like the apprentice of a good friend of mine might even actually be interested in assembling some of these boards, so we'll probably go and have a bit of a trial of that at some stage and see who's good at what and trade some skills. Anyway, I'll see you all in the next video.